Hello everyone, thank you very much for the introduction. Let's start with, for the people who don't know us, the question, who are we?
Who is who? That's me in the corner. So I'm Samba core developer for more than 23 years now. For the past 15 years, I'm also working on free APA, and that includes a lot of integration using Samba components. And occasionally I do some Kerberos development. Apparently, in the past 5 years, it's more and more to contribute to MIT Kerberos.
Yeah, my name is Andreas. I'm a free and open source hacker. I work on different open source projects, including libSSH, CMOCA, maybe you heard of them, and many more. I'm also a Samba core team member since 2010. And I also, as Alexander, if you work in this area with authentication, you also work on MIT Kerberos more or less. So I contribute also code to MIT Kerberos. Yeah, but this talk is about NTLM and how to get rid of it, but maybe first we need to look at what is it actually. So maybe already every one of you knows what it is, some heard of it, but you do not have the details, so now we go a little bit into the details. So NTLM is short for New Technology LAN Manager, and it's Microsoft's challenge response authentication protocol. Actually, it is very old. So it is a family of security protocols which dates back more than 30 years. So first there was LAN Manager, then was the New Technology LAN Manager, and then now what we have right now and most are using is NTLM v2 version 2 of it. And yeah, it's called New Technology, but after 30 years in cryptography, you are not new anymore. Now it's simply old crap.
Yeah, and the way how it works is effectively the client is saying, yeah, I want to authenticate. The server sends a challenge, and then client computes a response using this challenge and using the knowledge about the passwords. And then the server verifies response based on the hash of this password that was used to do this. And both kind of have these strengths and they have their own weaknesses. And in practice, it's used everywhere in many Windows protocols. It also, one of the things that make it kind of important is that it's the protocol of choice for authenticating if you don't have stronger protocols. And that's also a weakness in a sense, because if you have no stronger mechanism like Kerberos, many applications silently fall back to using NTLM. And that fallback as a weakness also something that prevents getting rid of it, because so many places they have relied on the fact that if something doesn't work, there's always NTLM. So testing these edge cases is a nightmare, and finding out where everything seems to be working only because it's falling back is a nightmare.
It's also a reason why a lot of customers don't know that their Kerberos is broken, because NTLM is still the fallback and it just works. But yeah, but why does NTLM need to go? So let's look a little bit more into the security problems it has. One thing is that the password on Active Directory is the NT4 hash, or called the NT hash. It is an unsalted MD4 checksum of the password. And that means it is pretty easy to crack. So if you get hold of the hash, it is not that hard in the meantime to actually figure out the password. We have strong GPUs. You can get them for a few bucks, rent them for a few bucks for an hour, and you can crack it. So there are pass the hash attacks, which means you steal the hash, and then it's as good as stealing the password because you can compute it. But there are also NTM relay problems that an attacker can relay the authentication to a different service and then authenticate. So there is no mutual authentication. You can prove the server. You can't prove the server who it says it is actually. And with Kerberos, normally you have a machine account and have there already a connection established or a challenge or a way to verify that the machine is actually the right one, and the DC you talk to is the right one you want to talk to.
And there's interesting kind of features out of it, which make it sticky. Since it's the thing that is present when the machine is not having any connection to anything else, it's still possible to verify it. Because it's unsalted MD4, it's not tied to a specific domain. So you can have this verification before you join a domain, and that's what happens on the Windows machines when it's by default installed. For example, the administrator account has the password with NTLM because there is nothing to tie it to the specific domain. And that just keeps the stickiness on it. Also, there is no other local protocol that could be used for replacing it. And attempts to replace it, well, they failed for a long time. Microsoft tries to replace NTLM publicly since 2013. People who were advertising it and doing this work already retired from Microsoft. And it's still being replaced. It's not a joke. It's the reality and the complexity of the problem, not even the technical one. There's a lot of organizational issues.
Yeah, so Microsoft and everyone is more or less preaching since 2010, stop using NTLM. And in 2023, they announced they will retire it as soon as they can.
And the interesting part was that looking through candidates for replacement, Microsoft came to the thing that they already use. That's a Kerberos. So Kerberos protocol is stronger than NTLM, even though they were sort of introduced at about the same time in the Windows environment, so early 90s, right? And the Kerberos kind of outlived it, so to say.
Yeah, and Microsoft announced that they will deprecate it probably in the second quarter of this year.
Yeah, we are at somewhat same, like quality-wise with Microsoft. We also announced that we will be doing localkdc and support only Kerberos, as they did. So announcement level, we are on par. The difference is that you can test our implementation today.
Yeah, so the future is Kerberos everywhere now, but there are complications. So why Kerberos? Kerberos solves all the NTLM weaknesses. So you have mutual authentication. Both sides prove their identity already. Passwords never travel over the network. The nice thing is you get single sign-on, so you get a ticket once and then you can use it all day. You don't have to re-enter your password all the time. It is a standard protocol. It is, there are RFC for it. It is actually the industry standard for a lot of companies, like Active Directory is using it. Free IPA is also rolling it out and using it. There is MIT and Kerberos, so there are two open source implementations of it. It is already
I want to give a heads up for or highlight for one of the unusual kind of parties that you don't think about when you talk about Kerberos. It's the Morgan Stanley. Morgan Stanley runs Kerberos for more than 30 years, and they publicly admit that. So the whole infrastructure in Morgan Stanley is using their own custom MIT Kerberos implementation. And that's a huge one. That's probably one of the biggest in the world, aside from Active Directory. So that shows how good technology is and how good it is towards the solving real problems, not just in IT, but where IT is used to deliver business value.
Yeah, so there is also one nice thing. Kerberos is around for a long time already. So most daemons who are out there more or less have support for Kerberos already.
Yes, but there are missing pieces and there are problems. Where is the
just one small question. If I do an own key using a password, that password is unsalted server side as well, right?
You mean on the Kerberos?
In the KDC database.
So the question was if the password is not traveling over the network.
No, it doesn't. Yeah.
It doesn't. Does it mean that the password is stored unsalted on the KDC side? No, it doesn't. The Kerberos uses encryption scheme where both sides basically have either pre-computed or compute on the flight the encryption key, which is then used to sign some nonce, some random data, and prove that both parties know the possession of the original key, not even the password itself, the key that they use to communicate. Password and key in this sense are roughly the same thing. Yes. So the missing piece is that Kerberos is effectively requires a triangle of participants. There is a client, there is a server, and then there is a party that issues tickets, the KDC, Key Distribution Center. And that third party is sometimes what makes it hard, because both server and the client, they need to have access to that third party. And if we have a standalone system, that system doesn't really have anything to talk to or any access. So the gap where NTLM is actually is used for, it doesn't need to have access to that line of sight KDC. So if the domain controller is not reachable, NTLM solves the problem. How we can make it reachable? Well, we can do some proxy. And this concept of proxying is going back for quite a long time. So I'm skipping intentionally this solution line because it's really the next slide, right?
Yeah, so in 1997, the MIT Kerberos folks designed something like a Kerberos 5 proxy mechanism, which is called IAKerb. So as we just learned, Kerberos normally requires three parties, a KDC, a client, and a service. But what if the client can only reach the service and doesn't have access to the KDC? What are we doing then? And IAKerb lets then the service, which could, for example, be Samba, then proxy the KDC exchange with the KDC on behalf of the client. So when you are connecting to a Samba server, then the Samba server has the connection to the KDC, the client doesn't have, but it will just forward all the tickets to the KDC and also back to the client. And that way we can exchange the initial Kerb TGG, the ticket granting ticket, and also get the service ticket we need.
So the catch here is that the service, for example, SMB server, sees all the traffic that the client does to the KDC. And theoretically, that should be alarming because, well, the service then might see the initial communication. But because Kerberos was designed for working in the unprotected environments like internet, and it's perfectly fine to use Kerberos over unprotected internet itself, we don't care. The whole communication is encrypted. There are catches, of course. There are some things that could have been modified, and some of the these rogue services could theoretically modify the packets that travel through it if used as proxy. But anyway, that service is the one that has access to KDC, and the client doesn't have access to KDC. So the service can issue whatever they want anyway, and we are talking to this service, not to anything else anyway. So it makes no kind of difference. It can impersonate us anyway. But the communication is protected, and the Kerberos protocol ensures that most of the details that could be modified can be actually detected and found. And the way it goes is you are a service. We start communicating as a client to you using your client protocol. So continue with SMB. SMB client talks to SMB server. During the negotiation, it says, I want to talk IAKerb, and the server basically forwards my tickets to, my requests, my packets to the KDC that it has access to. That KDC can be a real KDC, some Active Directory domain controller, or some other KDC. That the point here is that the service itself has access to it, but the client not required to have access to it. And it just translates the requests from the KDC to the client, from the client to KDC. They agree on something. The client typically needs to get the service ticket towards that service. And then from that point, they just exchange this service ticket as a part of the application protocol. Sounds theoretically nice. The covers the NTLM use case because client doesn't need to talk to the domain controller. It only needs to talk to the service itself. However, there are catches. And one of the biggest catches is Kerberos has concept of principles. Principles are defined within the realm, and that realm needs to be known. If the client doesn't have any idea how to communicate with the domain controller, how to know even the realm of that domain controller. And we need to discover it somehow within the process, because the service is just a pipe through which things, a proxy, through which things are going. It doesn't really help well there. IAKerb tries to solve this problem by using defaults of the service. If service has access to KDC, it can forward the packets there. Sure, it has the information what is the realm it is looking into. So we kind of using default realm of the service and tell to the client, hey, my default realm is this. So we now use this realm, and it doesn't matter that the realm is not resolvable. You cannot see the domain controllers of this realm on the client side, because all the traffic still will go through the service, and service know how to resolve it. Yep. So this is how the mechanism works. We send the empty realm. Empty realm is literally like empty string. And that it triggers the realm referral, pointing out to the realm of the right realm, the default one for the service. And implementation-wise, there's a bunch of attempts to implement it. Every decade there's a new wave of implementing it. So the current spec is implemented on the Windows side and is implemented in MIT Kerberos. For a long time we were waiting that Windows release will go out and we test against it and then announce that we support it and do MIT Kerberos release. That did not happen, but we released MIT Kerberos 122 last year that has this code and can do something.
Yeah, so when we started to test it, we figured out that some details of the draft spec for the protocol was not implemented or not implemented correctly. So we fixed that. Realm discovery was missing, so we implemented that. And also while we actually tested, we fixed a few bugs. And all of that is now in the current release, which is MIT Kerberos 1.22. That's the version you want if you want to do IAKerb.
Yeah. So anything below that is not supporting IAKerb, even if it's supporting IAKerb, because there is like no compatibility with the older ones.
Yeah, Samba by default uses Heimdall Kerberos, but Heimdall doesn't have any IAKerb support implemented, at least in the upstream version. But actually, Apple forked it, and they have IAKerb implemented, but it never got upstreamed.
And the reason for that is twofold. One of them is because they needed this for back to my Mac feature, which is a combination of sort of a VPN and the authentication using the IAKerb service, which then was retired in 2019. Yes. So the code is still in macOS, but you cannot easily configure it. And when you configure it, it kind of behaves strangely. And the actual source code for Heimdall modifications is on GitHub as a part of the code drop for macOS. The problem is that it uses the system services. So it basically relies on the out-of-process calls for Swift components that not easy to bring back into Heimdall code.
Yeah, so we learned that IAKerb works already just fine in Active Directory environments. You just need to implement the protocol and then you can start using it. But there is a last NTLM holdout, and that's standalone servers. And we should look into that now.
Yeah, and standalone servers, the ones that are not joined to any domain, they basically have their own database. That's the local security authority on this particular machine, and it has effectively NTLM hashes for the users and handled by that. And obviously it's only authenticated through that. And local user, when it logs in, the LSA is the services that it calls are basically using this LSA anyway. So from the application point of view, nothing needs to change, except if they explicitly use NTLM functions. And Microsoft then decided, okay, how we can replace this? Well, we can build a small shim over this LSA authority with the NTLM hashes. And instead of using NTLM hashes inside, let's put slimmed down Kerberos KDC there. That doesn't use LDAP, doesn't use the full kind of thing, but effectively it doesn't even need to communicate with the network, right? Because it's inside the local security authority. And that's what the local KDC essentially is.
Yeah, so how do we bring the Kerberos authentication to standalone machines? And the answer is the local KDC. And that is a Kerberos KDC, which is only accessible over local interprocess communication, especially for security reasons. So it runs on the machine itself. It runs on demand and not as a daemon. That's what we would like to see, but because sometimes nobody really needs it or not very often. So it should be turned off by default, but if you are requesting it, it should start up and be there. So that local services can directly talk to it over the Unix socket, Samba, SSH, any other daemon which has support for Kerberos. And remote clients which authenticate via IAKerb, then it just gets proxied again to over the Unix domain socket to the local KDC you are running.
Right, and 2 years ago we demonstrated this as a prototype at the FOSDEM, where we basically configured the MIT KDC to only answer on on the local host, 127.0.0 something, and it worked. Since that time, obviously, if you're only accessible locally, you don't even need TCP or UDP transports, right? So what we did is proved this into adding a truly local transport. That's the Unix domain socket.
Yeah, so with a local KDC, we eliminate this last holdout and can make use of it on standalone servers, so file servers only. Yeah, but let's look a little bit more in detail to the local KDC. And let's look at what actually do we need for a local KDC to work. So we need a Kerberos implementation with Unix domain socket support, and we want socket activation. That means the daemon isn't running, but when we are connecting to the socket to actually talk to it, then it is started on demand. And
again, this is technically not needed, right? You can run it always over localhost, bind to localhost, and it will be running there. But the side effect is that it's always running, so it's consuming some resources. If you don't need it, you ideally shouldn't consume resources. And that what kind of prompted us to look into a normal path of doing that is the socket activation, and socket activation over Unix domain sockets. Unix domain sockets also allow us to solve some other problems, like kernel actually able to defend access to the Unix domain socket by knowing who is talking on the other side. So you can apply SLinux protection and other mechanism, and you can also mount the sockets into containers, so you can do easier and nicer propagation of this information selectively and protect against various types of attacks. And that was a big part of work for MIT 122.1. The second part was when we realized that we want more than just a database that contains Kerberos principles.
Yeah, so for the local KDC, you also need a Kerberos database module and a database where your accounts are stored, whatever that database is. Then, for example, pre-authentication plugins, plugin for auditing, whatever to make that work and that you can understand what is going on or audit it. And, well, we need IAKerb support.
Right, and these modules, you already have a database. Kerberos has default database, actually two of them, one with the libdb and one with lmdb, and you can use them already. But if you want to add some additional logic on top of it, then your chances that you will have to modify these database drivers, and you don't want to modify them. They are doing their job nicely. You want to call them for storage kind of related activities and add the business logic on top of it. So a logical way of doing it is to have stackable modules. The one that handles the actual storage layer, the one that handles something on top of it, maybe even more, handling additional functions, and they kind of overlay each other. And this is the other part that was added to 122.1 MIT Kerberos, is the stackable Kerberos database layering thing.
Yeah, so what else do we need? We need management tools to administer it. We need plugins to actually integrate with the local accounts on that machine, and authentication mechanisms for these user accounts, for example, to bridge the authentication and authenticate via PAM or something like that.
So now this is going to the point where, okay, I have machine that already uses local accounts. So there is a plenty of accounts in its CPassVD. There is Shadows database that has the hashes and so on. Placing or plumbing the local KDC on top of it means somebody has to regenerate all the passwords, so generate the Kerberos keys. Somebody has to do something with it, and it's a nightmare because until you generated Kerberos keys, you cannot use Kerberos, right? So what we started looking at, how we can get around that, how we just enable local KDC and magically things are working for existing users who can authenticate using their passwords. This is what will be probably the most of the remaining of this presentation.
Yeah, so we call it the Kerberos project. It's a fun fair, right, with tickets. Yeah, we created a management tool called LKDC CTL. You can just provide setup to it. It will do everything to set it up. Install the KDC, configure it correctly. Also, not only the KDC itself, but a few other services. It requests certificates which are needed for PK init.
Yeah, so this is one thing that we will come into detail more. But in order to make things working with any authentication method, not just with passwords, we need a mechanism to protect this credential data that's going to be exchanged. And the mechanism in Kerberos world is called FAST, Flexible Authentication Tunneling, Secure Tunneling. And one of the ways of establishing that tunnel without having access to other Kerberos ticket is anonymous PK init. Anonymous PK init is basically, I only trust the certificate authority that issued the certificate to KDC. And then I am asking for a specific type of the principal, which is well-known anonymous. And then there's a generation happens that generates it on the flight. So you don't really authenticate the client, but you're issuing the ticket that is only used for the purpose of creating the secure tunnel. And this is how it looks like. Let's try.
Yeah, so here we just show a quick demo about how to set it up. You are just, as root, you are called the setup function, and then it will do everything for you. As you can see, it's also configuring the PAM authentication service, Samba SSSD, and then after some time, it will print when it is done. And now let's check if actually the socket is running. That's the important part. If we look at the status of the local KDC socket, then we can see that is set up and activated, so it's listening. But if we check if the service is running, then we see it isn't. So because it will get activated when we are start to talk to it.
Yes, and because the LocalkdC uses, that is our choice, uses a generated realm name, which is basically localkdc dot some random thing after it. Entering that realm as a user, it's cumbersome. We don't recommend. So we created some wrappers, like the localkdc control kinit for the kinit and for the user. It basically appends the realm for the username, so that we know directly what to use. This is preparation for having localkdc working together with any other domain join thing, so not just a standalone one. Or kadmin is basically running the administrative operations as root against the localkdc setup.
Yeah, last year we already had a local KDC, but the KDB plugin was written in C, and that limited us a little bit. So we decided to implement it in Rust.
Yeah. So the experiment was, okay, we want to have a safer code where we at least have some sort of a safer guarantees on how data is processed inside this plugin. Because we are not dealing with the database itself, we are dealing with the business logic. So we can guarantee what we do on our side. And to write the plugins in Rust, you need to have an interface bindings effectively to the C code, because the rest of the KDC is in C. So what we did is we tried to wrap these bindings. There are plenty of Kerberos bindings to Rust, but they all concern calling libkerb5 functions. There are 12 different plugin interfaces inside MIT Kerberos, and most of them are used on the server side. None of them are wrapped. So I looked into this code, how to do it, and actually used AI to generate most of these bindings because, well, it's one-to-one mapping of how many, 190 something functions. So it's perfect task for automation, right? And then apparently most of the good AI tools know how Rust works. Rust compiler enforces a lot of behavioral things, semantical things, and the architectural definition of it is very strongly affected. So basically, if it's generated some code that doesn't compile, it doesn't work. So you can set targets for doing that, and then we started to re-implement our plugins using this model, and it worked quite well.
Yeah, so the one is the KDB plugin, KDB UserDB, that is actually wrapping the KLMDB backend. So if we really need a database, but we need it and want to store something, we store it in LMDB. Then we implemented some logics you actually need for a local KDC, like service alias resolution. So that we can support actually connecting to IP addresses or different host names in a DNS server, which that machine might have, and so we can do reverse DNS lookups for that. For user local accounts, we use systemd userDB to get that information, and we get more information than just about local users. We can also, as soon as a service provides the Valink interface for a userDB, you get more information also from Winbind and SSSD.
So what it means that for the services like Samba or the SSH is using the host principle, right? We generate those keys. They are long-term keys. They exist on the system. They need to be in the Kerberos database.
Yeah.
They can be synthesized as well if we would be using more aggressively PKI inits or certificates and the stuff. They can be synthesized as well. But for the for the first phase, we just generate those keys. For the things like IP addresses, we do alias and stuff.
5 minutes.
And for the users, we don't store them because they already stored.
Yeah, so we can talk to UserDB. We have a Rust library for that. It is JSON. You don't want to do JSON in C. It's much nicer in Rust. So that was already there. That was also one of the reasons why to move to Rust. We have a pre-auth OTP plugin. We implemented a PAM radius tool that you can do PAM authentication. And let's look at this in the next demo, how that all plays together. So we create a local user, which is actually user add and calling password to give it a password. We call it Elmo here, enter the password.
So this user is not created in the Kerberos database. It's just a normal user on the system.
Yeah, we can switch to that user and now call localkdc init to get a ticket from the localkdc.
And one thing you see here is that instead of password, you've been asked to enter OTP value, right? Token value. This is because that string, that prompt, is hard-coded in the MIT library for OTP workflow. So we use this OTP workflow because it's not OTP related. It's the proxying out of the KDC to do radius authentication. And we do this radius authentication on Unix domain socket. The application that runs on that Unix domain socket on demand is doing PAM authentication against the local service. That's how we get the access to the password and ask this, using this password against the PAM authentication. And that's how we solve the problem with the user hashes in shadows being not what the Kerberos expects. To do that, we need to have a secure channel for communication between the client and KDC, and that's what this fast channel is used for, and this is why we use anonymous PKI.
So for Samba, we have an initial implementation of IAKerb. So you need to wire it there correctly and also do some logic to handle it. We have currently implemented it in the file server, so standalone SMBD, and the client also support that. So we use SMB client to connect to the SMBD, which is running there. You can see I just specified user Elmo, and it connected over using IAKerb. We can also just grab for that. Then you can see that it is doing IAKerb. We didn't specify a realm here because we have realm discovery, so it figured that out. But when you do that, we do Kerberos, but and we do get the ticket granting ticket, but it is not stored. But we have also implemented something which is called NetADS Kerberos Key init over SMB. You specify the server which you want to talk to and where we want to store it. Here we use the KCM, and then we get a ticket and it is stored in the C cache. And then now you can just use that ticket. I can remove the user Elmo, and then I do not get asked about the password anymore, and it will just use Kerberos with the ticket granting ticket we have connect.
So one thing you might notice is that we talk over IP address. We don't use the host name. There is no IP address based Kerberos service stored in the database. This is what our KDB driver does. It supports aliases for any IP address that is currently active on the machine. The same for the host names that this machine has for any of these IP addresses. This is the business logic we added. We can do that because the KDC runs locally. It sees the IP addresses on the machine. The standard type of running KDC somewhere in the network doesn't allow us to do that. So now there's a lot of future stuff, and we don't have time for that. We don't have time for future, it looks like. But there are biggest remaining pieces is the asynchronous use. IAKerb is part of the JSS API. You cannot use IAKerb in the raw Kerberos. And some of the operations there, they are synchronous. We need to turn them asynchronous. That's a huge problem. We need to add the IAKerb support to the other clients and to the kernel SMB 3 stuff. Interop testing with Windows, because we did not have access to Windows, is something we are looking forward for the IO lab this week. We need to do support or migration with the existing Samba databases, and that's where we are looking to Samba have support for UserDB and Varlink interfaces. We will see. That's a lot of things to do.
Yeah. So password changes, multi-factor authentication, optimizations to our PAM stack, Radius server, MS PAC support. There is now PIDL rewritten in Rust.
Yeah, we hope to get something usable soon, but there are packages that you can try already built for Fedora. So if you're interested, please come to us and we can discuss.
And